Hi, we continue the branching introduction lesson, this time with a few examples to better understand the jump instruction. We begin with the first example called infinite loop.answer. Let's take a look inside. This is pretty much a simple program. We don't see so many new things here, maybe besides the jump instruction. I'll remind you that our program begins here. The first instruction is move ECX 0, which is going to initialize ECX with the value 0. Next we have a label, which is called myLabel. Then we have the inc ECX instruction, which is supposed to increase ECX by 1. Finally, we have the next instruction, jump myLabel. This instruction is going to jump to the location pointed by the myLabel label, which is here. Basically, it means that those two instructions, jump and then increase, are going to execute again and again. Basically, we are really stuck with those two instructions. This is an infinite loop. We are never going to get out of this loop. As an example, we will never get here. This instruction will never be executed. That is because we always jump back to myLabel. This is a pretty strange example, but it is very educating, because this kind of infinite loops might happen to you at some point, maybe without your intention. Let's run this program and see what happens. What is the effect of this program? We first save this file, then we open a console, and we are going to assemble this program. Next, we run the program. I press the return key, but it seems like nothing really happens. The program just waits and waits. It doesn't finish. And this is pretty reasonable. We have this infinite loop. Probably at this point, ECX is increased and increased. And sometimes it becomes 0 again, and then it increases again. And nothing interesting really happens. We are just stuck with those two instructions, inc and jump. Maybe we can get some more information about what happens if we take a look at the task manager. To open the task manager, click Ctrl, Shift and Escape. This is the task manager. Let's begin by looking at the Processes tab. We can see our program here, called infinite loop.exe. In the CPU column, we can see that this program takes 25% of the CPU. It sometimes changes a bit, but for the most part, it takes about 1/4 of my CPU power. Which is interesting. You might be wondering, why 25%? Why 1/4? The answer is simple in this case. I have a quad core, which means that my processor is divided into 4 semi-independent small processors. And currently, this program runs on one of them. As we can see in this picture, this is probably this core. as it has the highest CPU usage. I want to show you what happens if I stop the program, just to be sure that we understand how this is really working. I'm using Ctrl+C key combination to stop the program, to interrupt this program. We can see that very quickly the CPU usage became lower. There is still much CPU usage because of the recording software that I'm using. Note that if I run the program again, the CPU usage increases immediately, and we can see another peak here. If I stop it again, see what happens in this code. There is a decrease in the CPU usage. Now that we have seen this example, I want to discuss another idea regarding the jump instruction. It is a pretty simple instruction, but we can still do much with it, even with the very little knowledge that we have so far. Note that only with one instruction, with the jump instruction, which is so simple, we managed to take 25% of the CPU power of this computer. Next, we are going to discuss skipping. We want to skip a few instructions using the jump instruction. And this time we are going to write the code ourselves. Maybe it will give you a bit more experience about how to write code. We first copy this program, infinite loop, and paste it here to get a copy of this file. We are going to rename it skip.asm. Next, we open the file, which contains exactly the previous contents of infinite loop.asm. We begin by deleting all the stuff that we don't want, which is the main part of the program. Now we have an empty template. First, we want a program that is going to print three numbers. The number 1, followed by the number 2, and then the number 3. This is pretty simple. Finally, we are going to print 3. Good. This is a very simple program that just prints 1, then 2, and finally 3. Let's assemble and run this program, just to make sure. I open a command line, and then I assemble skip.asm. Everything seems to work fine. Now I'm going to run the result. And indeed I get 1, followed by 2, and then 3, as we expected. Now I'm going to change the program a bit. First I'm going to add a label called skipL here. At this point, nothing really changed, because as we have already discussed, the processor doesn't care about labels. So I can put as many labels as I want and nothing is going to change. Now we add an instruction. We add a jump instruction here, at this location. It will jump to the skipL label. Let's make it look nicer. This time we have a bit of a different program. We added this jump instruction and also this label. Take a few moments to look at this code and try to understand what is going to happen. Let's assemble this program and then run it to verify your guess. We first save this program. Next we are going to assemble it. The assembly process finished successfully. Next we are going to run this program. As we can see, only the numbers 1 and 3 were printed to the console. However, the number 2 was not printed. What really happened here? How come the number 2 was not printed? We do have this piece of code, which is move EAX2 and then call print EAX. However, we can see inside the source file that we skip this part of the code. We use the jump instruction to skip this part. So basically what is going to happen is this. We begin with those instructions, move and call. Then we continue to the jump instruction, which is going to skip those two instructions. And we are going to find ourselves here at this instruction, move EAX3, followed by call print EAX, which means that we are only going to print the numbers 1 and 3 to the console. The number 2 will not be printed to the console because those two instructions are skipped using the jump instruction. Let's try to summarize what we have seen in this lesson. We first seen how to create an infinite loop in the infinite loop.asm program. It was pretty amazing that using only a very simple instruction, only the jump instruction, we could really hold 25% of the CPU power in this computer. Next we have seen how to skip a few instructions in the skip.asm program, which means that we had those instructions inside the source file, but they weren't executed because we jumped over those instructions. I want to note that so far we have only seen some really simple branching constructs. Don't be worried, there are more branching constructs. Very soon we are going to see some more interesting branching possibilities. This is about what I wanted to show you for the jump instruction. See you on the next lesson.